Chemicals are used in workplaces every day to manufacture goods and perform services. Handling chemicals can be safely done by making sure you learn the hazards of each chemical and follow the correct handling procedures. To learn about a chemical and its correct handling procedures, you should read each chemical's Safety Data Sheet, or SDS, receive hazardous materials training, and read the company's hazmat plan. Other resources include the Department of Transportation, or DOT, Hazardous Material Table, and the GHS label. Learn the chemical labeling system. All chemical containers must be labeled with exactly what is inside. Learn how chemical labeling is handled at your company. Receive training. Employers should provide training in the use of personal protective equipment. Additionally, employers should cover hazardous material handling procedures to reduce employee risk of exposure to hazardous materials. The employer is required to train employees on the hazardous material plan at least once per year. Know where to find the SDS. Employees must have access to the SDS for every chemical at the plant. These files contain important information for handling a specific chemical. You should know where the SDSs are stored, read the SDS for each chemical you are working with, and understand its compatibility with other chemicals. Learn about your employer's hazardous materials plan. Your employer's hazardous materials plan includes individual rules and procedures for handling hazardous materials. This plan should be available to all employees at all times. This plan is based on each material's SDS, so it is often located near these forms. Your employer must notify you of its exact location. One of the keys to safely handling any chemical is to reduce or prevent exposure to the chemical. This can be done by wearing the correct PPE described in the SDS and using engineering controls to manage the chemical. These prevention measures help workers stay within their permissible exposure limit, or PEL. Use engineered controls. Engineered controls, including ventilation and exhaust systems, should be present when dealing with chemicals to help avoid and limit exposure. Wear personal protective equipment. Obtain training in the proper use of personal protection equipment when handling a chemical. Information regarding the proper PPE is listed on the SDS for each chemical. This may include goggles, gloves, and respirators. Chemical spills increase exposure risks and result in unplanned downtime. They can also lead to the pollution of water, air, and soil. Every workplace is required to have a spill prevention and emergency response plan in place. This plan describes the proper storage and handling techniques of chemicals. It should also cover prevention techniques like how to inspect the condition of containers. The Spill Prevention and Emergency Response Plan should also describe measures to take in the event of a chemical spill. Unfortunately, no document can cover how to handle every chemical spill, so response training must be done well before a spill occurs. The most important step a worker can do when finding a spill is to immediately notify their emergency response team. Safe storage of hazardous chemicals is important in protecting a company's employees and property. A hazmat storage area has two functions: to safely store hazardous chemicals and to keep them clean. In order for a storage area to fulfill its role, there are several rules that should be followed. Store material based on compatibility. Identify storage areas with signs. Use original storage containers. And do not store near heat or ignition sources. Flammables should be stored with other flammables, oxidizers with oxidizers, and corrosives with corrosives. Incompatible materials must be stored so they cannot be exposed to one another. Proper signage may prevent accidental exposure to hazardous material. It also helps prevent incompatible materials from being stored together. Use the original containers from the chemical manufacturer. If you must change containers, make sure the new containers are designed to withstand the effects of the chemical over time. Store flammable materials in a well-ventilated area that is at least 50 feet away from any heat or ignition sources. Smoking must be strictly prohibited. Reduce chances of explosions by storing explosive materials like propane in a room with explosion-proof lighting that does not spark. A chemical storage area must be able to protect materials from the effects of weather. Wind can bring dirt and other contaminants. Direct sunlight can create a fire hazard. Water can ruin most chemicals and their containers. Most chemicals are stored so they remain stable near room temperature. An ideal storage area is climate controlled at all times. Some chemicals break down over time, causing them to no longer work properly or even to become unstable. The length of time a chemical can be stored before using it is called its shelf life. Chemical stocks should always rotate so that the first chemicals in are the first ones used. This helps manage inventory and ensures chemicals are used within their shelf life. Even with the proper safeguards in place, accidents may still happen. Keep emergency spill control and firefighting equipment accessible at all times near the hazardous material storage area. Firefighting suppression equipment includes water hoses, extinguishers, and an automatic sprinkler system. The area itself should also be made with fireproof construction, since fire can damage a chemicals container even if it's not flammable. One of the easiest ways to ensure that chemicals remain clean is to maintain good housekeeping routines in the storage area. Containers should be stored upright where the labels can be easily read. Any spills should be cleaned up immediately using the procedure outlined in the chemicals SDS. What is this worker doing wrong? What is this worker doing wrong? What is wrong here? What is wrong here? What is wrong here? What is wrong here? Most industrial chemicals are highly toxic to the environment. In fact, a single gallon of a chemical can contaminate up to 1 million gallons of water. As a result, the Environmental Protection Agency, or EPA, regulates their disposal to limit the likelihood of pollution. The EPA provides guidelines that describe how to handle and dispose of chemicals without dumping them or throwing them away. Each state also has their own procedures based on these guidelines. When handling hazardous materials, take precautions to protect drains. Never pour any amount of hazardous material down a drain. If a hazardous liquid accidentally goes down a drain to a sanitary sewer, notify your supervisor or team leader immediately so they can contact the local authorities like the sewage department. The proper procedure for chemical disposal is different for nearly every chemical. Always refer to the SDS for the correct instructions. The most common form of on-site chemical disposal is to simply separate and collect it. When it is ready for removal, contact the nearest government-regulated disposal company to handle its transfer and destruction. Some hazardous chemicals can also be recycled. A lubricant is a common example. Lubricants like oil, grease, and graphite are vital to the machinery of industry to reduce heat and wear. These materials are often petroleum-based, which makes them toxic and flammable. In many cases, lubricants can be removed from a machine, cleaned, and put back into the system. In larger operations, recyclers are built directly into the machinery. Why is it critical for companies to find ways to recycle materials? Most facilities that do not recycle lubricants store waste oils and greases in approved containers until they can be picked up by their local recycling company. Often, these containers are kept in the lubricant storage area. Other facilities may have underground storage tanks. If you must dispose of waste lubricants, determine where the waste storage is and put them in their proper containers. The Department of Transportation, or DOT, regulates hazardous material transportation in the United States for all modes, including road, rail, waterway, and air. Many of the DOT's regulations are similar to OSHA's workplace regulations, but there are some key differences. For one, the DOT has issued its own labeling system, although it is also based on Globally Harmonized System, or GHS. In fact, the DOT was the first U.S. government agency to adopt GHS, and it greatly influenced the system's development. Why is it critical for hazardous materials to be labeled while being transported? The DOT's labels closely resemble the GHS pictograms, except DOT labels have a United Nations UN identification number and no standard border color. Each label has 4 key elements: color, symbol, UNID, and classification. The DOT uses bright colors to identify types of materials. This draws attention to the placards so that workers, emergency services, and the public can identify dangerous materials while they are in transit. The DOT placard also makes use of the GHS pictogram system, and it introduces symbols for radiation and biological hazards. The 4-digit number within the placard refers to the United Nations transportation number for that material. The UN number is used because it is recognized internationally. Every hazardous material has its own number. For example, UNID 1977 refers to compressed nitrogen gas. The DOT also classifies each substance into one of 9 categories based on their physical properties. For example, Class 2 materials are gases. The 4-digit UN ID must always be present with the warning label. However, there are thousands of hazardous chemicals that can exist in several forms, so it is not possible to have labels for all of them. Therefore, the DOT allows the use of a generic warning label, but it still has to be accompanied by a separate orange panel with a black border containing the UN ID. Both labels must be located side by side at all times. There are 9 classifications in the DOT Hazardous Material Identification System. These classifications label hazardous materials packages and the vehicles transporting them. Class 1. Explosives. Class 2. Compressed gases. Class 3. Flammable liquids. Class 4. Flammable solids. Class 5. Oxidizers. Class 6. Toxic or infectious. Class 7. Radioactive. Class 8. Corrosive. Class 9. Miscellaneous. And other. Explosives are divided into 6 subclasses based on how likely they are to detonate. Division 1 explosives are the most dangerous, and Division 6 explosives are the least dangerous. Class 2 represents compressed gases. Pure oxygen has its own label since it is highly combustible. Poisonous gases must be marked inhalation hazard. These placards are used to label flammable liquids. In some cases, the placard may include a name like gasoline. Class 4 materials are flammable solids that use a red and white placard. There is also a blue placard used for solids that react violently with water. Class 5 materials are oxidizers, which greatly increase the combustion rate of fires. This includes organic peroxides that are extremely dangerous since they can also explode. Class 6 materials include poisons and infectious materials. Poisonous materials are toxic to humans through direct skin contact, ingestion, or inhalation. An infectious material is any substance that causes disease in humans or animals, like viruses and bacteria. Class 7 includes materials that, if released, could contaminate the environment. These materials are rated by how radioactive the material is, with 1 being the least dangerous and 3 being the most dangerous. There is also a placard specifically for fissile nuclear fuel. A corrosive substance is capable of permanently harming living tissues on contact, like acids. The DOT uses Class 9 for materials that do not fall into other classes, but still might harm people or the environment. One common example is dry ice, which is carbon dioxide in its solid form. The dangerous placard is used on shipping containers that are carrying 2 or more chemicals that are so unalike that they need separate placards. This helps keep the placard space small. The environmental hazard placard does not have a specific class number, but it is still used when a chemical can harm marine life. Every person involved with shipping, transporting, or receiving hazardous materials must have training in the DOT's regulations. These regulations provide the key actions that the shipper must take to ensure that hazardous materials are safely transported. The first step in shipping hazardous materials is to review the hazardous materials table published by the DOT. This table contains an alphabetical list of all materials the DOT designates as hazardous. It provides directions for the packaging, labels, UN ID, and paperwork required when shipping these materials. Once you have located the material in the hazardous materials table, compare its information with information on the safety data sheet for the material. Follow the proper methods for packaging the hazmat according to the Hazardous Materials Table and the SDS. These regulations must be followed when shipping hazardous materials. Regardless of the DOT labels used on the outside of the shipping package, every hazardous material inside the package still has to follow OSHA's HazCom or HSC regulations. This means the chemicals themselves must have a full HazCom label. The shipping paperwork for hazardous materials always follows the same format. The first page is the manifest, which is a document that contains a full list of the cargo. It must list hazardous chemicals first and provide a basic description of each one along with their potential hazard. The paperwork must also include an emergency response phone number that is monitored at all times, as well as the shipper's certification. All pages must be numbered and arranged in order. The shipper must provide the proper placards to the carrier of the hazardous materials. Placards are placed on the front, back, and both sides of the vehicle carrying the hazardous material. When receiving hazardous materials, do not allow the truck to be unloaded unless you can positively identify the material present on the truck. OSHA strictly forbids shipping packages with GHS pictograms when it is already required to have a DOT label. The only time GHS pictograms are also used is when the hazard is not listed in the hazardous materials table. OSHA made this ruling because having two different labels that address the same hazard can confuse people handling the chemical. According to the hazardous materials table shown, what DOT placards should be used to ship a quantity of methyl dichlorosilane? Pictogram. According to the hazardous materials table shown, what DOT placards should be used to ship a quantity of methyl dichlorosilane? Cross-reference the hazardous materials table with the SDS shown to determine what type of DOT placards should be used for shipping. Which of the following GHS labels are compliant with the cylinder shown?